actually. Are we happy with the water cycle? Fabulous. So what else happens with our weather? So we've got sun, we've got thunder and lightning, yep. So we know how thunder and lightning.
Electrical particles.
Yes, that's pretty much. So what happens is, like, when it's quite windy, clouds rub against each other, and then this kind of like takes electrons from one and puts them on another cloud. So some clouds would be slightly positive, some would be slightly negative, and eventually when you get a strong enough negative charge building, kind of like in the sky, the difference between the ground and the clouds would be strong enough for the actual kind of like lightning strike to go.
Wait, sorry. What was that for lightning?
Yes. So we'll talk a bit about static electricity in the afternoon, but what happens is when two surfaces rub together, so for example two clouds are rubbing together, so eventually kind of like electrons would jump from one body to the other, so you get like a cloud that's really negatively charged, and that charge, if the storm continues and there's a lot of friction and a lot of things moving about, will increase and increase and increase, and eventually the difference in the electric charge of the cloud and the ground would be big enough for the lightning to actually strike. So, anything else that we have in our weather? Snow. So what's the difference between rain and snow?
It's colder.
It's colder.
It's solid.
Yes, that's a really good. Yes, it's a different state. So it's fluffier as well, usually. Yes. Yes, and that's another good experiment to do. So because of the travel today, I didn't get any ice with me. But if you put some icy water, kind of like in a jar, a bottle, and leave it for a while, you will see the condensation eventually forming on the outside. So you can then start talking about when things get colder, water condenses and so on and so forth. And you can talk about the different states of matter. Janie gave me a fabulous idea for an activity about density and the states of matter. So if it's okay, I will give it as an extension activity. Just fabulous. So, and why is that difference between snow and rain? So when does it rain? When does it snow? Yeah, that's exactly it. Yes, there is a little range where it can snow, and outweight generally, if it's higher it rains, if it's lower, yeah, the air dries quite a bit as well. So yes, the temperature then starts playing effect as well. So I've been quite optimistic today, and I'm trying to monitor the greenhouse effect. So I've got a thermometer here and a thermometer in a jar, and it hasn't quite worked yet, but we'll leave it for the day. So another thing that we've got in our atmosphere is wind. So what creates wind? Airflow, absolutely. But what causes that airflow to happen? Yes, so it is an equal pressure from one area to the next.
Air over the tides, the movement of the sea and the tides, the tidal forces.
Yes, definitely affects kind of like wind direction and speed. Anything else?
Yeah, the topography, because like mountains, if they're close together, then the wind, the air, as she says, pushes them so it becomes tighter.
Yes. So if there's two mountains, kind of like it funnels the air from a smaller through a smaller kind of like area, and that increases the speed of wind. And also when the wind is moving on top of the sea, there's nothing really to stop it, so it tends to get stronger and stronger, whereas as soon as it reaches land, there's trees and mountains and things like that, so it tends to eventually kind of like lose its strength. So what activities would you do to show young people about the wind?
I like pyramid kites, we've just done that this long ago.
Fantastic. So the idea that they thought is pretty much kind of like a piece of fabric,
Yeah.
and then you can tie it with kind of like a rubber band on a piece of wool and kind of like make a wind sock. And that is quite a good activity from the point of view that you can give it to a young person or a person of all ages and make them run, and you can see that they can create wind just by the speed that they move. So back to what creates the wind. So what drives the wind kind of like on the whole of the earth?
The rotation.
The rotation has a lot to do with it, but it doesn't actually start the process.
The heat from the sun.
The heat from the sun, that's exactly it. So because of the shape, the equator is usually closest to the sun, irrespectively of the kind of like angle of the earth. So that means because of the shape, the air in the equator is always getting warmer and it always rises up, but then the air in the polar kind of like regions is always getting kind of like depressed and it's always going down. So the air from the equator is always trying to reach the polar regions, and because of the Earth's rotation, you can start kind of like different movements of kind of like of wind. So just kind of like as a rough analogy, so if you were standing on the equator and you were trying to throw a ball at your friend in Scotland, so if you threw it, by the time they caught it, it will always land on the right rather, because of the Earth's rotation, and like the equator is always spinning kind of like faster than the poles. And the same thing, if you threw a ball from the equator to a friend in Australia, it will always land on their left. So wind on the north hemisphere tends to move in a counterclockwise direction, and in the south it tends to move in a clockwise kind of like direction. Is there anything else that we can do to show them kind of like wind?
We look at the tree in the garden shaking. We look at the trees in the garden shaking.
That is a wonderful idea. So trees in the garden, anything else that you might do? Bubble? Excellent. And I did bring some bubbles here. So does anyone want to make some bubbles?
Yeah.
So, and when we're making bubbles, a very interesting thing to think about is like what shape are water droplets when rain falls.
I like big bubbles.
Tear bubbles.
Well, actually, they're round. It's a very similar thing to. Well, the reason that we've made them in the two is because they're willing to visual just so you can get stronger wings. And is it quite fast? Is it slow today?
So I'm the...
So I think you can start using mathematical language. They might ask you about kind of like the colors. Would you feel comfortable to answer about the colors in there? Fabulous. And then bubbles can help explain the fact that water droplets are always round as well. They're not tear-shaped and they're not like pancakes. And it's for the same reasons as the bubbles, it's just surface tension.
Do you think you're very good? I'm